What if we get interrupted by
We might. Okay, so to use the quadratic formula, first of all, we have to make sure our quadratic equation is in standard form. So quadratic means it's a polynomial equation with a degree of 2. Okay, and we just sang this. And if you look on my YouTube channel, there is a version where I rapped it. In case the actual singing wasn't to your liking. There are different versions.
Why is there a stapler on the desk?
It probably got left there from decorating for
Staple with it.
what do you call it? Homecoming? Yep. If you would like to put it on that back table so it's not your way, that'd be great. Alright. So in this problem our A is an understood 1, our B is a positive 5, and our C is a positive 2. So when we do the opposite of B, the opposite of B would be negative 5 plus or minus the square root of B squared, which is 5 squared, minus 4 times A times C, which is 4 times 1 times 2, all over 2 times A, which is 1. So this is 25 minus 8. What is 25 minus 8? 17. So this describes the two solutions. Okay, so one solution is negative 5 plus the square root of 17 over 2. A second solution is negative 5 minus the square root of 17 over 2. Okay, now we'll do the same thing here. Our A is 2, our B is negative 3, and our C is 2. So in this one, x equals the opposite of b, so it becomes a positive 3, plus or minus the square root of negative 3 squared. Whenever we square a negative number, it becomes positive. But if you punch it into your calculator, guys, your calculator does exactly what you tell it to. So if you want it to square negative 3, you have to put it in parentheses. These are not equivalent. This is the opposite of 3 squared. So your calculator would give you negative 9 because that's what this is. This is negative 3 squared, which is positive 9. So if you're using technology, if you're using your calculator and you're squaring a negative number, make sure you put it in parentheses because your calculator will do exactly what you tell it to. It doesn't understand that you meant for it to square negative 3 unless you put that negative 3 in parentheses. Okay? So minus 4 times 2 times 2. That's A and C. A and C. All over 2 times A. So this gives us 3 plus or minus the square root of 9 minus 16. That's negative 7. All over 4. Well, this can simplify some more because we know that when we take the square root of a negative, it's actually an imaginary number. See, this one has 2 solutions, but these solutions are not real. These are real solutions, but they're irrational. They're not rational. These are not even real. These are complex solutions. So classify your solutions above as real or complex. If your solutions are real, classify those as rational or irrational. So once again, what is a rational number? It's any number that can be written as a fraction. That can be written as a fraction of integers. Now, the square root of 17 is not an integer. So, this first one is real. These are real answers, but they are irrational. And then these answers are actually complex. Okay, now, this won't factor, and this won't factor. Now, all the polynomials we've done so far that we've graphed, we've been able to graph because they factor. So what we're going to start looking at today is, what do we do when they don't factor? are there ways that we can find all those zeros or all the roots when a function does not factor? And there are some ways, and they're not that hard. Okay? Now, starting tomorrow, you must have your graphing calculator though, because that's going to be a shortcut for us. And you want to be able to take advantage of the shortcut. Today I'm going to teach you what we would do without technology. Tomorrow we're using that technology and we're going with it, and we can do a lot more once we have those calculators. So if any of you have a calculator contract for me, make sure I get that before you leave class today so I can have your calculators for you at the beginning of class tomorrow. Okay, let's take a look at where we're headed with this. What are we learning today and how is it going to be helpful? All right, so we have another polynomial function. This is a cubic. Can you factor this cubic? No, I can't. No. Can we use the quadratic formula to find the roots of this?
Yes.
It is a cubic. What kind of function can we use the quadratic formula for? A quadratic function. So we can't use this we can't use quadratic. No. This is a cubic. And we can't even put it in quadratic form. You know how sometimes when we had like x to the 4th plus 7x squared plus 12, we can kind of think of this as being in quadratic form and write it like this. We can't even think of this one in quadratic form. There's no way to do that. So, now, how can we find the roots of this function? What we're going to do is we're going to use something called the rational root theorem to see if there are any rational roots. And if we can find rational roots, then we'll use synthetic division. To get it down to a quadratic. Because once we get a function down to a quadratic, then we can always use quadratic formula. Rational root theorem. What this tells us is you can find, it's time guys, it's time to learn. You can find all possible rational roots by taking all the factors, positive or negative, of the constant divided by the leading coefficient. So P is represents all the factors of the constant Okay, now after our around the room game, do you guys have a better understanding of what the word constant means? It's the plain old number. It's the one that doesn't have any variables with it. That's the constant. And we're going to divide that by Q, which represents all the factors of the leading coefficient. And now, of course, this is when it's written in standard form. So standard form means we start with the largest exponent and work our way down when written in standard form. Now, what we're doing is finding all the possible. That doesn't mean they actually all are roots. It just gives us all the possible ones. Now, if there are any rational roots, they will be in this list. So, let's take this equation right here, that x cubed minus 8x minus 3. And let's talk about what P and Q are. In this problem, P represents all the factors of 3. Well, that's a really nice problem because what are the factors of 3? The only way to get 3 is 1 times 3. That's the only way to get 3. It's prime. Okay? And then Q represents all the factors of the leading coefficient. And in this case, it was x cubed, so that's an understood 1, isn't it? That leading coefficient is an understood 1. So the only factor of 1 is 1. So when we do all the plus or minus all the factors of P over Q, it just looks like this. It's positive and negative. 1 divided by 1 is 1. 3 divided by 1 is 3. Those are our only choices for the possible rational roots. Positive 1, negative 1. Positive 3, negative 3. That's it. That's all of them. And if you'd rather write it like that, plus or minus 1 and plus or minus 3, I'm okay with that. But I'm also okay with you putting the plus or minus only once. Okay, now, we talked about last week, you can actually determine if a value is a root by plugging it into the function, and if we get out 0, then it's a root. So remember, whenever we plug in any of these values and we get out 0, then we know it's a root. Okay? So we've got 4 to try. Now, if none of these work, that would tell me there are no rational roots. Okay, if you were born January through March, you test f of 1. If your birthday falls April through June, you test negative 1. If you're July through September, you test 3. And if you're October through November, you test negative 3. So you're plugging these values into the equation we have. And once again, that equation is on your sheet. You can still see it. It's f of x equals. Now, make sure you plug it in parentheses here. X cubed minus 8 times x minus 3. Okay? All right, try those. See what you get. You try yours, get your assignment.
Miss Willis?
Yeah. You're testing negative 1. So you're plugging negative 1 into this function.
So we're at.
All right. My winner babies. When you plugged in positive 1, what'd you get out? Did you get negative 10?
Yes.
So it's not a root. Very good. Not a root. Okay? My spring babies. When you plugged in negative 1, what'd you get? 4. So what does that tell us? It is also not a root. All right, summer babies. When you plugged in 3, what'd you get? 0. Ooh, 0. That's what we were looking for. This one is a root. All right, negative 3. Okay, so negative 27 plus 24 is negative 3. Did you get negative 6? No? All right, so if we plug in negative 3 and cube it, we get negative 27. Oh, no. Negative 27, yeah, plus 24 is negative 3, minus 3 more is negative 6. So this one is not. Now, actually, I could have stopped right here. Because right here I discovered that 3 is a root. And I'm starting with a cubic. So if I take a cubic and divide it by 1 root, I'm down to a quadratic, and I'm good. So as soon as you get to the first one that works, if you're starting with a cubic, that's all you need. If you were starting with a 4th degree polynomial, you need 2. Because when you divide synthetically twice, then you get it down to a quadratic. So your whole goal is to get this down to a quadratic, whatever function you're starting with. All right, so synthetic division. It's 1, 0, because there's no square term, negative 8, negative 3. We know 3 is a root. Now, we don't do the opposite here because this is the root. It's not the factor. We only do the opposite when it's the factor. So you do the same thing. And then, let's remember synthetic. You bring down the first one, you multiply, you add, you multiply, you add, you multiply, you celebrate. You knew it was a root, so you knew this had to be 0. Because if this is a root, there is no remainder. Now what we're left with is x squared plus 3x plus 1. A quadratic that does not factor. So we go. Negative b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a. Okay, so this is negative 3 plus or minus the square root of 5, because 9 minus 4. 4 times 1 times 1, 4. 9 minus 4 is 5, all over 2. So this cubic has 1 rational root. My roots are x equals 3 was one we found using the rational root theorem. Then we did synthetic division, and this is a rational root. These are irrational roots.
This will be 4, like if you got negative 3 plus or minus the square root of 5 and then over 2, do you want us to go to that extra step?
No.
Okay.
Stop right there. I see 1, 2 with the positive, 3 with the negative. You're good. It's 2 times a, and a is 1. Okay? All right, so we have 4 that we're going to practice together in class, and then you just have 2 for homework. Okay? So the first 2 are cubics. All we have to do is get them down to a quadratic. We're good. So the first 2, we only need 1 rational root. The second 2 are quartics. They're 4th degree polynomials. So we have to get 2 rational roots. So here's the process. The first thing we have to do is figure out what those rational roots are. So it's all the factors of the constant. Well, the factors of 4 are 1, 2, and 4. Those are all the things that we can multiply and get 4. Leading coefficient, once again, is 1. It's really nice of us. Every single one of these. We were not mean today. So, when you divide by 1, it doesn't change anything, does it? So, all we have to test are 1, 2, and 4. Plus or minus 1, 2, and 4. Okay, so we need to do f of 1, f of negative 1, f of 2, f of negative 2, f of 4, f of negative 4. Now the first one we get to that gives us 0, we stop. We don't want to do too much work. Okay, so this is how we're going to do it. You guys do f of 1. This row, f of 2. This row, well, no, f of negative 1. Negative 1. F of 2, you guys, negative 2, 4, negative 4. All right, test them.
So how did you get 2 and 4?
All right, what can you multiply to get 4? What are the factors of 4? Think about, just like when we were factoring, we had to think about all the different ways you can multiply to get that number. Same thing here. So how can you multiply to get 4? 1 times 4 and 2 times 2. So that's what we mean by
And did you get 4 from like the constant?
yes.
This is not a root.
Negative.
Not a root.
All right.
Wait.
All right, f of 1, what'd you guys get? You got not 0. F of negative 1, what'd you guys get? Not 0. So this one should have been 5. And this one should have been negative 3. Okay. So this one doesn't work. This one doesn't work. F of 2.
Not a 0.
Not a 0. Did y'all get 30?
Yeah.
Okay. F of negative 2.
5.
I'll go with 2. So it still doesn't work. F of 4.
I got 152.
When you're bad at math.
152.
Yeah.
Doesn't work. F of negative 4. Woo! We found it. Okay. So, as you can tell, sometimes this is long and drawn out, which is why tomorrow is going to be nice when we use our technology. You still have to understand this part. But tomorrow, I'm going to show you how to use your technology to check these to see which one it is without having to calculate them all. Okay? So make sure you bring your technology. It's a huge helper. So we know negative 4 works, and that's all we needed. So we synthetically divide by negative 4. We pull down our coefficients and our constant.
What do we use positive for? Because that's the opposite.
Okay, this is a root, not a factor. If this is the root, the factor would be this. Do you remember that from graphing? So we always took the opposite of the factor when we synthetically divided. But if this is the root, we don't take the opposite. Okay? So we're going to bring down that first one. We're going to multiply. We're going to add. We're going to multiply. We're going to add. We're going to multiply. We're going to have a little celebration on the inside because it equals 0. Well, the remainder is 0. We knew it should be, and it is. So now, this is my A, this is my B, this is my C.
Miss Wilby? Wait. That's a negative 4 under the 3?
Yeah.
Yes.
Why is it negative 4? Not
Because negative 4 times 1 is negative 4. Okay, so now I'm going to do quadratic. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And this simplifies to negative 1 plus or minus 1 plus 4 is 5 over 2. So these are 2 of my roots, and the other one I got right here, negative 4. And that's all of them. All right, here's my P, here's my Q, because it's in standard form. All the factors of 2 over all the factors of 1. So plus or minus P's over Q's, is plus or minus. The only way to get 2 is 1 times 2 over 1 is just plus or minus 1 and plus or minus 2. Those are the things we test first. All right, let's just start with f of 1. If I plug in 1, I get 1 minus 3 plus 4 minus 2. That's negative 2 plus 4 is positive 2 minus 2 is 0. I am done. I don't have to test anymore because the first one I chose to test gave me 0. When I plug in 1, 1's real easy. Yes, ma'am.
Why didn't you do 4 like you did number 1?
I could, but this one works. So if you want to plug these in,
No, at the top you did 1 and then 2 and then over 1.
okay, look at this one. This number is 4. What are the factors of 4? 1 and 2 and 4. So that's why I chose 1 and 2 and 4. This one is 2. So what are the things that we can multiply to get 2? 1 and 2. Okay? And when I test 1, it works. So I don't need to test anymore. I'm good. So now I'm going to do synthetic division by 1, which is really nice. And I've got 1, negative 3, 4, negative 2. I know I want to end up with 0 because I know this is a root, so there should be no remainder. I bring down the first one, I multiply, I add. I multiply, I add. I multiply, I get 0. Yes, ma'am.
Would that not be a negative 1?
Which one? Right here?
No.
No, right here?
Yeah.
Okay. So, if you have the root, you do not change the sign. If this were written as the factor, you would change the sign. But because it's the root and not the factor, we do not change the sign. So this is my A, this is my B, this is my C. So negative B becomes a positive 2. The opposite of B becomes a positive 2. Plus or minus B squared. If you are using your calculator, that negative 2 has to go in parentheses. Minus 4 times 1 times 2. All over 2 times 1. All right, negative 2 squared is 4. And 4 minus 8 is negative 4. What is the square root of negative 4?
2.
2
Negative.
I. Because it is imaginary. So this is 2 plus or minus 2i over 2.
And then can you use
And 2 divides into both of those. So it's 1 plus or minus I. So my roots are the 1 that I found here, and then 1 plus I, and 1 minus I.
Wait, why is it 2i, not 4i?
Negative 4 and
What is, okay, so negative 4 breaks up into 4 times negative 1. The square root of 4 is 2, and the square root of negative 1 is I. Okay. So, number 3 is a quartic. It's a fourth degree polynomial function. So to get it down to a quadratic, we have to divide twice. Because the first division gets us down to a cubic, the second synthetic division will get us down to the quadratic. So, we need to find 2 rational roots. Not 1, 2 on number 3. So let's take a look at number 3 now. Okay, so possible rational roots. Well, this is easy because P is 2. So what are the factors of 2? 1 and 2. That's it. That's the only way we can multiply and get 2. And once again, we gave you a 1. So, my only possible ones are plus or minus 1 and plus or minus 2. Okay. Alright, I'm going to talk you through how I do these in my head. Alright, so first thing we're doing is we're plugging in 1. 1 to the 4th is 1. And then 4 times 1 to the 3rd. 1 to the 3rd is still 1. 4 times 1 is 4. And then 1 squared is 1, times 2 is 2. And then 1 times negative 5 is negative 5. Okay? Now, I always do things the easiest possible way for me. And when I look at this, these two make a positive 5, which is going to cancel with that. Negative 5. And then 2 minus 2 is 0. This one works. Okay? Now let's plug in negative 1. So a negative to an even power is a positive 1.
Can you just stop there?
Nope, that gives us 1, but this is a quartic, so we need 2 this time. Yeah. So a negative to an odd power is negative. A negative to an even power is positive. And a negative times a negative is positive. Alright. This should be 5. Sorry. Okay, so negative 3. Oh, no, I just totally left 1 out. That's 2 plus 5 minus 2. There we go. I needed 5 of them. So negative 3 plus 2 is negative 1 plus 5 is positive 4 minus 2 is 2. That one does not work. Alright, let's test 2. 2, 4, 8, 16. 2 to the 4th is 16. Do you see what's that on my fingers? 2, double it. 4, double it. 8, double it. 16. Counting on my fingers every time. Alright, so 4 times 8 is 32. 2 times 4 is 8. I can really go ahead and stop because I know I'm not going to get there. It's not going to make it to 0. And then negative 10 and negative 2 does not equal 0. I don't even have to add it up. I know it's not 0. So that one doesn't work.
So can we just
Can we just
assume
say
that
it's
one
this one and
works?
quit?
Can we assume that one works or no?
If it doesn't,
You're going to find out when we start using our technology that no, you can't.
But for now, we can just assume and not do it.
She just said no.
Sometimes the things you say let me know just how lazy you are. Negative 2 to the 4th is positive 16. Negative 8 times 4 is negative 32. And then positive 8. And then positive 10. And then negative 2. So this is negative 16. And 18 is positive 2. Minus 2 is 0. That one does work. Okay. Because I had done all the math, we could assume that the last one worked. But you're going to find out tomorrow that even though it's a quartic, you may only have 1. And what can we do with that? So, you may have no rational roots. And then what do we do? Okay, so we do have 2 rational roots. Our rational roots for this problem are 1 and negative 2. Which means we're going to do something cool. We're going to synthetically divide twice. But you never, ever, ever start over. You always use the answer from the first time when you're doing the second time. Okay, so the fire drill got us, but I'm going to finish up this last example here. You bring it down, you multiply, you add, you multiply, you add, you multiply, you add, you multiply, you add. Now we're going to test that last root, negative 2. We test it on the answer from the previous one. You bring it down, you multiply, you add, you multiply, you add, you multiply, you add. So now what we're left with, once again, is the quadratic. And you can use the quadratic formula to find the remaining factors. So we know 1 is a factor, We know negative 2 is a factor, and if we use the quadratic formula here, we find the other factors are negative 3 plus or minus the square root of 5.
Where were you? We were looking for you. Quiet. Miss Ruby.